Hello friends, so today we'll learn how to design a DFA ending with double one. For that, my idea is to first of all write all the 1-bit, 2-bit and 3-bit combination, and then we can figure out the strings which needs to be selected. So 1-bit strings are 0, 1, your 2-bit strings are 0, 0, 0, 1, 1, 0 and 1, 1. 3-bit strings are 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and so this is the better idea how you can select the strings. Now find out the strings which needs to be selected. Design a DFA ending with double one. So this is the string which needs to be selected. Then this is ending with double one. So this is the another string which we need to be selected. 0, 1, 1, 1 is the third string. So out of all the strings, these three strings, we know that this is the string which is of minimum length. So we know that the number of states will be determined by the minimum length string. So minimum length string is having length 2, so the number of states will be 3. And we know that we have 5 tuples in a DFA, out of which we have to study these 3 tuples. The first tuple is total number of states, and here the total number of states will be 3. And out of which the one state will be your initial state and the other state will be your final state. So let us represent your initial state with Q0. Then we will also have an intermediate state, let us represent it with Q1, and then there will be the third state, that is your final state represented by your concentric circle. The next step that you have to do is simply input the minimum length string on the initial state and reach to the final state. So you have input 1 and 1. So we can clearly say that double one is being accepted by this particular DFA because it starts from the initial state and reaches to the final state. Now we know that the input alphabets are 0 and 1, and I have told you in my earlier videos that this set of input alphabets should have a transition for all the set of states. So for this state we have to make the transition for 0 and 1. Similarly for this state as well we have to make the transition for 0, 1 and for this state as well. So for this state we have already made the transition for 1. So we can simply rub it. For this state as well we have made the transition, and we are left with the third state. We have to make the transition for this 1. We have 3 states, so there are 3 possibilities. It can go this way, it can go this way, or it can have a self loop on the same state. So we have to justify which one of them will be correct. Now let's find out the strings accepted by this given state. 1, 1 is a string accepted. Then if you take this self loop, which is optional, then we have 1, 1, 1, 3 ones. Then we have 1, 1, 1, 1. It means 4 ones. And similarly we'll have 5 ones. And this is the pattern which is being followed by this particular state. If I talk about this state, what is it accepting? To know this, we have to take this particular loop and we have to find out the strings. So when I take this transition, then what are the type of strings accepted? 1, 1, then 1, 1, 1, 1, 4 ones. Then 1, 1, 1, 1, 1, 1, 6 ones. So it is accepting even number of ones. Coming to this transition, it will accept 1, 2, 2 ones. It will accept 2 ones, then 1, 2, 3, 4, 5 ones. Then 1, 2, 3, 4, 5, 6, 7, 8. 8 ones. So what we have to find out of all these transitions, which one is correct. So we will simply say that this particular self loop was accepting maximum number of cases because 2 ones are being accepted by these 2 strings, 3 ones is not accepted by this particular transition, and 4 ones is not accepted by this transition but not accepted by this one. If I talk about 5 ones, which is accepted by this one but not this. So we find out that this transition as well as this transition are missing some of the strings which needs to be accepted because we have to design a DFA which is ending with double one. So obviously all these strings are ending with double one, but they are not accepted by this and this transition. So we will follow this particular rule as our final transition for 1. So now we have made the transition for all the ones, and now we are left with transition of zeros. As it is saying that all the strings should end with double one. So again here 0 has 3 possibilities. Either it can have a self loop. If it has a self loop, then we can contain any number of zeros followed by double one. So it will always end with double one. But if I take this 0 here, then it will accept one string, that is 0 1, which is not ending with double one. If I take this transition, it is accepting 0, which is again not ending with double one. So these two transitions are wrong, and we can say that this 0 will have, this Q0 will have a self loop of 0. So we are done with this transition. Now we have to make the transition for Q1. Now Q1 again can have 3 possibilities. If we have a self loop of 0 here, then it will accept 1 0 1, which is not ending with double one. So obviously this is incorrect. If we have a transition here, it will accept 1 0, which is not ending with double one. So this is also incorrect. So we are left with the third transition, that is here, and we see that if you start from the initial state and if you include this particular transition, it will accept 1 0 1 1, 1 0 1 1, which is ending with double one. Even if you take this self loop 1 0 0 0, any number of zeros, then again ending with double one. So this transition is maintaining the requirement of our question. So this is correct one. Then this 0, the transition for this 0 is also done. We are left with the third 0. Again, if you have the self loop of 0 on this state, it will accept a string 1 1 0, which is not ending with double one. So this is incorrect. If we have a transition over this state, then again include this transition and accept a string 1 1 0 1, 1 1 0 1. So it is not ending with double one. So we can clearly say that this transition is also incorrect. So we are left with the third transition, third state. We'll make it here and we'll see what string is accepted if you include this transition. So 1 1 0 1 1, 1 1 0 1 1. So it is ending on double one. After doing this, also there can be a possibility that it can be incorrect, but we'll verify it with the help of the strings that we have shortlisted. So double one is clearly acceptable by this DFA. 0 1 1, 0 1 1 is also accepted. Talking about 1 1 1, 1 1 1 accepted. We have to also verify the strings which should not be accepted. 0 ending on the non-final state. So this is your final state. Though it is your initial state, but it comes under non-final state. So this is your non-final state, this is also your non-final state. So 0 0 is not accepted because it is ending on non-final state. 0 1 ending on Q1, which is a non-final state. 1 0 ending on Q0, which is a non-final state. Again, when you will verify all the remaining strings, you will find out that they are ending either on Q0 or Q1, which are the non-final states. So in this way we can say that this is accepting all the strings which are ending with double one. Even when if you are not satisfied with this, just take a random string 1 0 0 1 1 0 1 1. So this particular string is ending with double one. So obviously it should be accepted, and we will verify it with the given DFA. So we have 1 0 0 1 1, then we have 0 1 1. So it is accepted, 1 and 1. So it is accepted. If we have a string like this and we have to verify whether it is being accepted or not, let's see. It is not ending with double one, it will not be accepted. Let's see if it is accepted or not. 1 0 1 1, then we have a 0 and we have 1 and 0, which is ending on non-final state. So this is not being accepted. So this is the correct DFA for the given question. Thank you.